Welcome to another edition of Math Snacks with Miss Glovely, Miss Wonderful, and Miss Pointer. Miss Pointer, you've become quite a regular on the primary Math Snacks. We sure enjoy having you.
Well, I enjoy being here. You guys are a lot of fun.
Awesome. Well, today we're going to start talking about the difference between a pattern versus a function, because sometimes that's a confusing thing for us, for students, and for us to be thinking about. So let's start out by looking at a pattern.
Oh, my fish are back.
Hey. I see lots of similarities here.
I do too.
What do you notice about the fish?
Uh-oh, there's a different, well, he's kind of different and kind of the same.
Well, are you looking at the size here?
Sizes, but
yet
they have similarities too.
Well, their properties are pretty much the same with the lines going through on the sides.
The stripes.
And yeah, those stripes,
well,
those vertical stripes.
Well, let's talk about, because we could look at this pattern on a lot of different attributes. I mean, if we had done something like this, then what attribute we might be looking at in that pattern?
Large, small, large, small.
Okay.
Well, and then you'd have to try to figure out how you could continue that pattern.
What would come next?
Oh,
I
think one of those large ones would.
You guys are so awesome.
Those
We could
are fun.
also be thinking about it in color, because we could have done something more like green, orange, green.
Oh, yeah.
So lots of ways to look at the pattern.
Right.
But the way I'm going to ask you to look at the pattern today is, let's go back to the stripes.
Okay.
How many stripes are on the first?
Three.
I
see three.
Okay. And if I said, now how many stripes do we have?
In all?
In all.
6.
Oh.
And how many in all now?
Oh,
9.
And how many in all now?
12.
Wow.
Oh, this is easy.
Yes.
I get it.
Good.
Okay. So what is the pattern? If I added another fish?
If you had another fish?
Well, let's just do it, just so that we show a visual.
Okay. We're going to add another fish.
15.
I agree. I concur.
Okay. And how did you concur on that? How did you know it was 15?
What did you do, Miss Pointer?
Well, you can count on to figure out how many more. But if you already have the pattern, we kind of figured out that the function was adding 3 more, so you could just add 3 more to the 12.
Was it the function?
Was it the function adding 3?
Or was it the
Well, I
pattern?
think
That's that confusing
That's
thing.
the confusion.
You know, it is the pattern.
Yes. The pattern here is actually
Adding.
a plus 3, or add 3. Okay. So that's the pattern. But this is a typical way we look at patterns. But I want to show us, we're going to talk about it in a t-table.
Oh, that
Because that's where some of the confusion comes into, is when we look at it as, this is called a growing pattern. And so if we had done, I'm just going to go back to this.
Okay.
And we looked at the color and we said green, orange, green, orange, green, orange. That is not a growing pattern, but
AB pattern.
it's an AB pattern. And we also have, and we'd say it's AB, AB. We also call it a repeating pattern, okay? Because there's 2 types of patterns. We have a repeating pattern, or if we say that you add 3 each time, it's called a growing pattern. Kind of a little different than that repeating pattern, because we keep growing it. We're saying 3, 6, 9, 12, and we're adding 3 each time. But it's sometimes we get confused, not just between patterns, but also the function. So let's look at what that might look like.
That
Can
sounds
we
good.
use the same example with our
We
fish?
we sure can. Let's use that exact same example. So let's get rid of
Need new
this.
white paper?
We need new paper. Let's use the same example with the fish.
Okay. You want all 5 fish?
Let's start with, let's start with 1 fish.
1 fish. Okay, 1 fish, 2
Let's
fish,
start
red
with-
fish, blue fish.
Well,
that's
no,
a
we don't
different-
have blue
That
fish and
is
we
a
don't have red fish.
whole different-
Other math snack.
Okay?
Or some other snack.
Just another way. And I know at the primary we talk a lot about patterns, but there's another way we can look at it is with functions. And we can use either a t-table that goes like this. Have you seen one of those before, guys?
I have.
Or a horizontal t-table, which goes like this. But it depends on where we put things. So if we say this is the number of fish and we say this is the number of total stripes. Okay? Number of, maybe I should put the word total in there.
Probably.
That'd
Okay.
be good.
Number of total. So let's start with that one fish again. If we have one fish,
One. Oh, look, I'm trying to be Miss Wonderful. One.
you've got one
Is
fish.
that your fish right there? Or is that what you're using? Okay.
How many stripes are on that fish?
1, 2, 3.
3. Okay. If we have 2 fish,
We have 6
how
stripes.
many stripes?
6.
Okay. And if you need to count them, we could go back and we could actually
Sure.
physically count those 6 fish. And if we have 3 fish, how many stripes do we have?
9.
You're just so quick. Don't give us any think time, do you?
Okay, I'll stop.
This time I'm going to skip. I don't want you to think about 4 fish because go back to this repeating pattern. I'm going to throw this back in here again. Okay? If I keep going in order of the 1, 2, 3, here's your 3, 6, 9,
Sure.
which is right here. That's your growing pattern. So if you always go in that order, we can look at the pattern, and if we look at the pattern,
We just add 3 each time.
we just added 3 each
There it
time.
is.
There's the pattern.
But the problem with that is I always would then have to know what the number above was. And so if I now wanted to skip to 10 fish, I'd have to come on down adding 3 until I got to 10.
Probably so, but once you understand this concept a little bit better, you could probably even predict the number here and here, could you not?
So let's say we want 10 fish.
Hmm.
And we don't want to do 4, 5, 6, 7 and look at the pattern.
I don't want to add 3 until I get down to the 10th one.
We want to go this direction, which is the function.
Oh, yeah.
So think of the pattern is if we go this way, but the function is going across.
So it's like going from 1 to the 3, and 2 to the 6, and 3 to the 9, and finding what the commonality is there.
So if we had 10 fish, how could we find out?
Any ideas?
Well, I'm thinking you just take 10
Mm-hmm.
and, gosh, I would just say times 3
Okay.
in my mind.
Mm-hmm.
That works, or else I would have to think of 10 fish with 3 stripes and count those all individually if I needed that visual representation.
Right.
You
But
might
you've-
add
you-
3 10 times, right?
But you've
Sure.
hit on that function because look, it works for each one of the examples.
You're
1
right.
times 3 would give me 3 stripes. 2 times 3 would give me 6 stripes, and 3 times 3 would give me 9 stripes.
What would we do to help those kids that need that visual times 3 in there somewhere? Would we need to provide that for those kids or not, do you think?
What do you mean? Ask the question one more time.
Well, I'm thinking for those children that do not understand this function that when you go across, you're multiplying by times 3. And so I am trying to think of how we would help children get a visual somewhere in through here to help them remember, even though they know their times tables maybe, it'd be difficult for some children to remember this in a T-chart, perhaps. I don't know. I've not worked with children in multiplication.
Well, I think if you draw this arrow,
Uh-huh.
that helps them know we're looking at the relationship between these two numbers, not the relationship to this number to the one above it.
Right.
So sometimes just by drawing that,
And I noticed too how carefully this has all been you've described it with pictures, you've been given instructional clues with pictures, and then you've wrote it out down here, so I see that would provide a lot of support.
and there's a lot of relationship between, and I think we talk a lot about the relationship between multiplication and division and addition and subtraction, but there's also the relationship between repeated addition and multiplication, because that's what multiplication is. It's just repeated addition over and over. 10 times 3 means we've got to have 10 groups of 3. We're adding the 3 stripes from this fish to the 3 stripes from this fish to the 3 stripes from this fish, and keeping a running total.
So as a teacher, how would you have children demonstrate understanding besides just writing the answers in?
Oh, I think I would do several things. One, make sure we don't put the numbers in order. So instead of going, I mean, at the primary, I'd start 1, 2, 3.
Sure.
But then making sure I mix it up like this. And then even say, what if I have in the pool, we'll put it in a story problem. In the pool, there are a total of 36, and I probably ought to put it in another tea table. Here, let's do this. If we had another tea table here, and it's the same thing, and I said, in the pool, there are a total of 39 stripes. How many fish are in the pool?
Oh.
So then they'd almost have to, what they have to do is think backwards, or
Sure.
they would have to take out their fish
And
and
get
count
39
out
stripes.
39 stripes, and then see how many fish they ended up with.
I've also seen that same story problem, and you're probably thinking the same thing, but where they actually draw the pond and they actually draw the fish and put the stripes on them and everything to provide a visual representation or a
In that case, that'd be
representation.
visual. Yeah, you could do it either kinesthetically, hands-on, or draw it with pictures, or get to the abstract, which is really what we do a lot of talking about. Is it's really important to go from concrete to a pictorial.
Your pen's running out.
It is to the abstract, and oftentimes in math, we jump from concrete to abstract and we forget that pictorial representation. So that's a real good idea you have of letting them draw the fish.
Well, I think I would know as a teacher if children were having a hard time providing that piece for demonstrating understanding. I would know if children were not putting in the right amount of fish, if they were forgetting the stripes, if they weren't putting enough stripes on the fish.
That would
It
give
would
you
help
the-
me to understand whether they have it, I believe.
Can we talk about one more pattern or function using this other type of function table so
Yep,
that we can
let's-
see that? Because typically the type that we've drawn already is the type that we would typically see, but when students are approaching pre-algebra and algebra, we like to arrange the numbers in a different way. Looks like a parking lot. It still does the same job, but we
I
just
like that. It looks like a parking lot.
It does kind of look like a parking
That's
lot.
what it reminds me of.
Okay.
And this time we're going to use dinosaurs.
Awesome.
Cool.
Okay, so if you have one dinosaur, how many legs do you have?
Oh, can I put?
You
I
need your
probably
labels. You need
this
your
is
labels.
my number. Can I just put my
You can-
number of
D for
number
dinosaur.
of D?
Okay, and we're looking at his total number of legs.
Number of legs.
Okay, so
Okay.
one dinosaur,
One dinosaur.
4 legs.
You
Great.
see him? He's kind of like
I can
fell
see
over.
him.
I
He fell
fell
over.
I can see him better when he's laying on his tummy or on his side.
On his side.
Okay.
Yep.
One dinosaur has 4 legs.
Okay, a different kind of dinosaur, but
Total of 2 dinosaurs.
So we need to have 8 legs.
8 legs. Let's skip to not 3, but like 5.
okay.
Oh.
There's one.
So we don't start saying, well,
That's a
we
good
add
idea. There's a
4.
pattern.
Yeah.
Yep, there
Okay.
we go.
5 dinosaurs
Have
have
a total of
4,
Oh, so that would be
8, 12, 16, 20.
Uh-huh. I just think it's important that we show this other way of recording the data, because when they do get up into those upper grades, this is what they will start to see. So
Well, I'm glad you mentioned that, because I think recording is just as important as interpreting it. So I think that they will they not? It sounds to me like they're going to see things like that anyway.
right.
So interpreting it.
So I have a story problem for us.
Okay.
If the dinosaurs are going out, what do dinosaurs go out on hunts for?
Well, I'll tell you what. I think you need to be talking. Well, they're herbivores, and carnivores.
Herbivores.
So it looks like to me we've got mostly. Well, let's just take out the T-Rex here, and we'll
Okay.
have all herbivores.
Okay. there we
Okay.
go.
So now they are looking for greens.
Okay.
Those star leaves that they just loved off the
Okay.
land before time.
So there are some dinosaurs, herbivores,
Herbivores.
looking for some greens, and there is a total of 32 legs. How many dinosaurs went out on that hunt? How would you solve it if you're not to
Well,
the abstract?
Let's get some
We'd
more
have to get some more
Where
dinosaurs.
did that bag of dinosaurs go?
Here's the dinosaurs.
Oh, goodness. Thank you. That's wonderful. Okay.
I
we
put
need to
one
make
more
sure
in
we have
there.
Pointer.
So now we're to 24 legs. We need some more.
Here
We
we
don't
go.
have 24. There we've got 24, 25, 26, 27, 28 legs.
Okay, and here's another
Need
one.
another one.
My
That's
fingers
going to
in the
be
way.
32.
29, 31, 32. So how many
2,
dinosaurs?
4, 6, 8.
Oh, and
8.
I loved how you counted like that.
By
Nice job.
twos.
By
Ooh,
twos.
awesome.
Cool.
Okay, well, thank you for joining us in another episode of Math Snacks where we discussed the difference between a pattern versus a function.